If all the elements in a row or column are zeros, then the value of a determinant is always equal to lambda 1 into B2C3 minus lambda 1 into C2B3 is the expansion of the second part. Keep it in mind, it seems like a column, not a column, it is a row. First element of row 1, first element of row 2. R3 dash is equal to R3 minus R1, this minus this, 1 minus 1, 0, C minus A, AB minus B. Hello dear students, welcome to this session of Basics Maths class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PUC College. In the previous classes, we have studied regarding the properties of determinants. So far, we have discussed 5-6 properties. Let me discuss the remaining properties. And today, based on those properties, I am going to discuss few problems. So it will fetch us 3 marks for you in examination. Definitely we will get 1 3 marks question from problems which are based on the properties of a determinant. So based on properties of determinants, you are going to get 1 3 marker question. Now let me discuss the remaining 2 properties, then we will go to the problems. Now first property, that is the property today I am going to discuss is property number 6. If all the elements in a row or column, so if any row or column contains zeros, then the value of a determinant is also equal to 0. That is the meaning. So if all the elements in any row or column, if all the elements in any row or column are zeros, then the value of a determinant is also equal to 0. So any row or column contains all the elements as 0, then the value of a determinant is found to be 0. That is, let us consider, let us come to the proof. Let delta is equal to A1, A2, A3, B1, B2, B3, third column 0, 0, 0. According to the statement, what is the value? Then the value of this determinant is equal to 0 because all the elements in third row are zeros. All the elements in third row are zeros. According to definition, the value of this determinant is equal to 0. Let us take a proof. I'll prove this. Let me see whether I will get the answer or not. Proof. What is given? Delta is equal to A1, A2, A3, B1, B2, B3, 0, 0, 0. Expand this. Plus, minus and plus. So, A1 into, delete the row and column containing this. B2 into 0 is 0. Minus 0 into B3 is 0. Next, minus A2 into, this is gone. 0 into B1 is 0. Minus 0. Again, plus A3 into, delete the row and column containing A3. 0 into B1 is 0, minus 0 into B2 is 0. So, this is equal to A1 into 0, minus A2 into 0, plus A3 into 0. So, 0 minus 0 plus 0, this is totally equal to 0. So, that means if all the elements in a row or column are zeros, then the value of a determinant is always equal to 0. That is the meaning of this property. Very important property. Now let us take an example. Let us verify with an example. Now let us come to an example. Let me take 2 rows, 2 column. Let determinant of A, yes, A determinant of A is equal to 2, 4, 0, 0. So this is 2 rows, 2 column. Since according to the definition, the value of this determinant is equal to 0 because all the elements in second row are zeros. Multiply, see, 2 into 0, 0, minus 0 into 4 is 0. This is equal to 0. If I take another matrix, A is equal to 4, 5, 0, 0. See, here all the elements in the second column are 0. According to the statement, this is equal to 0. Let me check. So, 4 into 0, 0, minus 5 into 0, this is equal to 0. So, this is in case of 2 rows and 2 column is concerned. Let us take a 3 rows, 3 column determinant. Let us consider determinant of this 1, 2, 3, 4, minus 1, 2, 0, 0, 0. So, according to the definition, the value of this determinant is equal to 0 because all the elements in third row, all the elements in third row are 0. Third row are zeros. So that is, let us expand this, plus, minus and plus. So 1 into 0 is 0, minus 0, minus 2 into 4 into 0 is 0, minus 0, plus 3 into, delete this, 4 into 0 is 0, minus 0. So this is 0, 0, 0, totally equal to 0. So if all the elements in a row or column are zeros, then the value of a determinant is also 0. Now let us take one more problem in 3 rows and 3 columns. Let us consider if A is equal to determinant 2, 4, 1, 0, 0, 0, 3, minus 1, 2. Now, according to the definition, the value of this determinant is also equal to 0 because all the elements in second column, all elements are 0. In second column, all elements are 0. Therefore, the value of a determinant is equal to 0. Let us check. So, expand, plus, minus and plus. This is 2 into 0 into 2 is 0, minus into minus plus 0, minus 0 into any number is 0, plus 3 into, this is gone, 4 into 0 is 0, 1 into 0 is equal to 0. So, this is 0 minus 0 plus 0, this is equal to 0. Right. So, that is the property and the example based on those properties. So, in general, if all the elements in a row or column are zeros, then the value of a determinant is always equal to 0. Now, let us come to the next very important property, that is property number 7. What is the statement? If sum or sum, few, if sum or all the elements of a row or column of a determinant are expressed as the sum, sum plus sum of 2 or more terms, then the determinant can be expressed as the sum of 2 or more determinants. If sum or all the elements of a row or column of a determinant are expressed as the sum of 2 or more elements, then the determinant can be expressed as sum of 2 or more determinants. Let us consider delta is equal to first row contains sum of 2 elements. Let us call it as delta. Let us take delta is equal to A1 plus lambda 1, A2 plus lambda 2, A3 plus lambda 3. Remaining B1, B2, B3, C1, C2, C3 as it is. Let us take first element as A1 plus lambda 1, A2 plus lambda 2 plus A3 plus lambda 3, where A1 plus lambda 1, lambda 2 are any constants or any other values. So here the first row contains the sum of 2 terms, A1 plus lambda 1, A2 plus lambda 2 and A3 plus lambda. According to the definition, if any row or column contains sum or more than 2 terms, this can be expressed as sum of 2 individual determinants. Consider all first terms A1, A2, A3. Here lambda 1, lambda 2 and lambda 3. Remaining columns are same. Columns, that is row number 2 and row number 3 are same. Second row is same. B1, B2, B3, C1, C2, C3. Again your B1, B2, B3, C1, C2 and C3. This is the meaning of the statement, that's all. So, sum or all the elements of a row or column of a determinant are expressed as the sum of 2 or more terms, like this, sum of 2 or more terms, then the determinant can be expressed as sum of 2 or more individual determinants. So, here first row contains sum of 2 terms, A1 plus lambda 1, A2 plus lambda 2 and A3 plus lambda 3. Second row and third column are same. This can be expressed as sum of 2 individual determinants. First determinant contains first row as first element. Second determinant contains first row as the second element. Second and third row are same for both the determinants. So, A1, A2, A3. Here lambda 1, lambda 2, lambda 3 plus B1, B2, B3, C1, C2, C3 are same. Now let us expand this. Let me expand this. Now let us come to the proof. Now proof. This is let delta, yes, let delta is equal to A1, A2, A3, B1, B2, B3, C1, C2, C3 and lambda 1, lambda 2, lambda 3 B1, B2, B3, C1, C2. Then this is A1 plus lambda 1, A2 plus lambda 2, A3 plus lambda 3, B1, B2. So this is equal to the same. Now let us take this is to be proved. To prove that, let me take this RHS. Prove this. Plus, minus and plus. Expand. So if I expand this, what I am going to get? A1 plus lambda 1 into multiply B2C3 minus B2C3 minus C2B3 minus A2 plus lambda 2 into, delete the row and column containing this, B1C3 minus C1B3. Next, plus A3 plus lambda 3 into, delete the row and column containing that, B1C2 minus C1B2. Now expand this. While expanding, just take lambda, just first multiply with A1 all the elements, then with lambda 1 for this, multiply with A2 for these two elements, then with lambda 2, again A3 with this for these two elements, and with the lambda 3. Let me take A1 first. A1 into B2 C3 minus A1 C2 B3. Again plus into minus, here expand. So A1 into B2 C3 minus A1 into C2 B3 plus lambda 1 into B2 C3, again minus lambda 1 into C2 B3. Next, similarly with this element, minus A2 B1 C3 minus into minus plus A2 C1 B3. Next with lambda 2, minus into plus minus lambda 2 into minus lambda 2 into B1 C3 minus lambda 2 into C1 B3. Similarly, come to this last, plus A3 into B1 C2 minus A3 into B2 C1. Again with lambda 3 plus lambda 3 into B1 C2 minus lambda 3 into C1 B2. So this is the expansion. So if we expand like this and take all the elements, just equate the terms which contains lambda one side and the remaining terms on the other side, you can verify that it is found to be of the form A1, A2, A3, B1, B2, B3, C1, C2, C3, and lambda 1, lambda 2, lambda 3, and B1, B2, B3, C1. So let me check this. Now, so this can also be written as, other way of expanding this, other method to expand this as, so let me expand like this, or you can verify like this, A1 plus lambda 1, A2 plus lambda 2, A3 plus lambda 3, B1, B2, B3, C1, C2, C3. This is RHS. Now expand like this, A1 plus lambda 1 into B2 C3 minus C2 B3 minus A2 plus lambda 2 into, this is gone, B1 C3 minus C1 B3 plus A3 plus lambda 3 into, delete this row, B1 C2 minus C1 B2. Okay, I'll explain in a simple method, simple way, let us take very easiest method to solve this. So first expand with respect to first plus, minus and plus, expand. Now just, so this can be written as, first take all the terms containing A1 B2 C3 minus A1 C2 B3. Next minus this, multiply with A2 B1 C3 minus into minus plus A2 C1 B3. Next let us come to this third, A3 A3 into B1 C2 minus A3 into C1 B2. Now plus, let us take lambda terms, plus take lambda 1 into this element B2, lambda 1 into B2 C3, plus into minus lambda 1 into C2 B3. Again minus lambda 2 into B1 C3, minus into minus plus lambda 2 into C1 B3. Again plus lambda 3 into B1 C2, minus into plus, it is minus lambda 3 1 to C. So if you observe carefully, so this is nothing but this first form, first term is equal to A1, A2, A3, B1, B2, B3, C1, C2, C3, plus second terms are nothing but A1, lambda 1, lambda 2, lambda 3, then B1, B2, B3, then C1, C2 and C3. You will get. See, observe carefully. If we expand A1 into B2 C3, A1 into B2 C3 minus A1 into C2 B3, A1 into C2 B3. So this is correct. Next, come to this. Expand this, lambda 1 into B2 C3, lambda 1 into B2 C3 minus lambda 1 into C2 B3. This is also correct. So therefore, this can be expressed as the sum of two individual determinants. So therefore, this is your required LHS. That's all. This is the easiest method. Let us follow this method. Okay. Now, come to this. I will explain. So, according to the statement, if any row or column contains sum of two individual terms, then the matrix can be expressed as the sum of two different determinants. So, or two individual determinants. So, here let us consider, let A1 plus lambda 1, A2 plus lambda 2, A3 plus lambda 3, B1, B2, B3, C1, C2, C3. So, according to the statement, this is equal to first elements A1, A2, A3, B1, B2, B3, C1, C2, C3 plus lambda 1, lambda 2, lambda 3, B1, B2, B3, C1, C2 and C3. Expand this and show that is equal to that much. So, A1 plus lambda into B2 C3 minus C2 B3 minus A2 lambda 2, this is gone B1 C3 minus C1 B3 plus A3 plus lambda 3 into, this is gone B1 C2. So, multiply with A1 first, A1 into this, A2 into this, A3 into that. Again take lambda 1 to B2 C3 minus C2 B3. Again lambda 2 into B1 C3 minus lambda 2 into C1 B3. Lambda 3 into B1 C2 minus lambda 3 into. So if you observe carefully, then this is of the form A1 B2 C3 minus A1 C2 B3 is the expansion of this determinant A1 into B2 C3 minus A2 into B2 C3. So therefore this first part can be written as A1, A2, A3, B1, B2, B3, C1, C2, C3 as a determinant. And the second part, you expand this. So if you expand lambda 1 into B2, C3, lambda 1 into B2, C3 minus lambda 1 into C2, B3 is the expansion of the second part. So therefore, this can be written as the determinant lambda 1, lambda 2, lambda 3, B1, B2, B3, C1, C2 and C3. That is the RHS. So LHS is equal to RHS. That is regarding the property. It's very important property. Hope you understood all the properties. These are the 7 properties which are very important for the point of examination. You may get one question from this for 3 marks. Otherwise, you may expect definitely a question based on these properties. Now, let us come to based on the properties, we are going to solve few problems. So these type of problems are very important for the point of examination. Definitely we will get a 1 3 marks question from this part. Now let us take first problem. I will solve few problems based on these properties. So what is to prove? Prove that or show that first row A, B, C, second row A plus 2x, B plus 2y, C plus 2z, x, y, z is equal to 0. Now what is the intention of this type of problems is simplify as much as possible. Without expanding, we have to prove this. Without expansion, they will ask, without expanding, without expansion, prove that, show that. So here, just use the properties or any property, you just simplify this to the simplest form in such a way that all the elements above the principal diagonal are 0 or below the principal diagonal are zeros, or if 2 rows, 2 columns are same, or all the elements in a row or column are zeros. then it will reduces to 0. That's all. So here, so to get this as 0 as the answer, what is the step? So either this must be converted into such a way that any two rows, two columns are same, or all the elements in a row or column are zeros. Now let us take the first LHS. This is LHS. Let me take LHS. A plus 2x, x, B plus 2y, y, C plus 2z, and z. Observe carefully. These are very important problem. Observe carefully. Show that A, B, C, A plus 2x, B plus 2y, C plus 2z is equal to x, y, z is equal to 0. Let us take LHS. What is LHS? A plus 2x, x, B plus 2y, y, C plus 2z, z. Observe carefully. Second row contains sum of two individual terms, A plus 2x, B plus 2y, C plus 2z. According to the previous property, if any row or column contains sum of two elements, then it can be expressed as sum of two individual determinants. So this can be written as, take first element A, B, C. Here also first element A, B, C. Now second element, split this as A, first element, second elements 2x, 2y and 2z. So I have splitted here A, B, C, 2x, 2y, 2z for the second determinant. Remaining are same, x, y, z, x, y, z. Got it? So this contains sum of two individual terms. So therefore this can be written as A, first element B, again first element C, second element 2x, 2y and 2z. Now since this is equal to, you just keep this as it is, ABC, x, y, z, plus here you can remove two common factor. If you remove two common from the second column, then this second row it becomes ABC, x, y, z. Again it is x, y, z. Observe carefully. According to a property, if two rows, two columns are same, according to the property of a determinant, if two rows, two columns are same, then the value of a determinant is equal to 0. Observe here, first row and second row are zeros, are equal. Therefore, these two rows are equal. Therefore, this is equal to 0 plus 2 into here. Second and third row are same. Therefore, this is also equal to 0. 0 plus 0, this is equal to 0. That is your RHS. Very simple, 3 marks. Very simple. Easily you will get 3 marks. Nothing. See, observe carefully. First row is ABC. Second row contains sum of two individual terms. So take first elements A, B and C. Take second elements 2x, 2y and 2z. Then x, y, z as it is. Here two rows, two columns are same. This is equal to 0. You can remove two common factor from the second column. Again you x, y, z, two rows are same. So this is 2 into 0 is 0. So 0 plus 0 is equal to 0. This is the answer. Okay. Now let us take a similar type of problem. So the intention is just reduce to the simplest form. That means convert this to the properties, and using property you can straight away put the answer. Now let us take one more problem like this. Okay. Let us take prove that x plus y, y plus z, z plus x, z, x, y, 1, 1, 1 is equal to 0. So without expansion, so you should have to prove this is equal to the answer. Let us take LHS first. Let me take LHS. What is LHS? X plus y, y plus z and z plus x. Second row x, z, x, y, 1, 1, 1. So what is to prove this is equal to 0? Now what you are going to take? Observe carefully. See, very simple. Here this is first row, this is first row, row 1, row 2 and row 3. Now see here, observe carefully. If you add these two elements, x plus y plus z, you will get x, y, z. Y plus z plus x, you will get x, y, z. Z plus x plus y, you will get x, y, z. So you can remove x, y, z common factor. Then easily you can verify. So here taking, for this we are putting the property, taking r1 dash is equal to R1 plus R2. R1 dash is equal to R1 plus R2. So this is, second is same, Z, X, Y, 1, 1, 1. For this we are adding first element of row number 1 is X plus Y plus first element of row number 2 is Z. Similarly, second element. So that is Y plus Z plus X, Y plus Z plus X. Similarly, Z plus X plus Y. So this can be written as this is equal to, put it in order, X plus Y plus Z, Z1, again this is X plus Y plus Z, again X1, again X plus Y plus Z, Y and 1. So if I remove X plus Y plus Z common factor, if X plus Y plus Z is removed common factor, what you are going to get here? So I will remove X plus Y plus Z as the common factor. In the first row you are going to get 1, 1, 1. So whereas remaining Z, X, Y, remaining is Z, X, Y, Z, this is Z, X and Y, 1, 1, 1. So this is equal to X plus Y plus Z into, according to the property, if two rows and two columns are same, see here, first row and third row are same, therefore the value of this determinant is equal to 0. 0 into any number is equal to 0 or H's. That's it. Okay, let me check. I will explain once again. Come back to this. Take LHS, X plus Y, Y plus Z, Z plus X, Z, X, Y, 1, 1, 1. Taking R1 dash is equal to R1 plus R2. Or you can change here also, R2 dash is equal to R1 plus R2. So here also you can put, or there also first row or second row. So taking R1 dash is equal to R1 plus R2, just right away first write down second row and third row, Z, X, Y, 1, 1, 1. So we are changing the first row, not column. Keep it in mind, it seems like a column, not a column, it is a row. First element of row 1, first element of row 2. Second element of row 1, second element of row 2. Third element of row 1, third element of row 2. So first element of row number 1 is X plus Y plus Z. Second element of row number 2 is Y plus Z plus X. Third element of row number 1 is Z plus X plus this. So R1 plus R2, R1 plus R2, R1 plus R2. X plus Y plus Z, Y plus Z plus X, Z plus X plus Y. Put it in order, X plus Y plus Z, X plus Y plus Z, X plus Y plus Z is the common factor. So you can take this as the common factor out. So here X plus Y plus Z, 1, 1, 1, X, Z, X, Y, 1, 1, 1. Since two rows are same, then the value of a determinant is equal to 0. 0 into any number is equal to 0 is the simplified answer. So this is the easiest method to solve this problem. Okay, I hope you are all following. Now let us take one more problem. If you practice this, it will be very easy. What is the difference? What is the problem you are facing in this type of problem is the steps is entirely different. So you are not using the same steps. So it depends upon the problem. Depending upon the problem, we are going to use the steps. Okay. So for that, just practice. You will get an idea and you are going to solve easily without any risk. Let us take this problem. Now, prove that 1, 1, 1, A, B, C, B, C, C, A and A, B is equal to A minus B, B minus C and C minus A. So, this is also a very important problem. So, here let us take LHS first. LHS, let me write LHS 1, 1, 1. This is LHS. Again A, B, C, A, B and C, B, C, then CA and AB. Now what is answer you want to get? A minus B, B minus C and C minus A. You can use R2 and R3. So R2 dash can be written as taking R2 dash is equal to this minus this, R2 minus R1, and R3 dash is equal to R3 minus R1 or R2. Anything you can take. So let us take this. First R1 is same, R2 and R3. So R1 is same, 1, A and BC is same. You are changing R2 minus R1, subtract these two. R2 minus R1, this minus this. 1 minus 1, 0, B minus A and CA minus BC. Second row. Now next, what you are taking, R3 dash is equal to R3 minus R1, this minus this, R3 minus R1, 1 minus 1, 0, C minus A, and this is AB minus BC. Okay, so 1 A, B, C, first row are same, we are changing second row, R2 dash is equal to R2 minus R1, so this minus this, 1 minus 1, 0, B minus A, CA minus BC. R3 dash is equal to R3 minus R1, this minus this, 1 minus 1, 0, C minus A, AB minus BC. Okay, now see here, observe carefully. So according to a property, if all the elements above or below the principal diagonal are zeros, then its value is equal to product of principal diagonal elements 1 into BA into this. Since this, convert this C minus A to 0, that's all. So for this, let us observe, is it possible to take any common factors? So I will copy this for the next page. So let us go to the next page. In the first column we have 1 0 0, 1 0 0, again A, B minus A, C minus A, B minus A, C minus A, again BC and CA minus BC, CA minus BC, and last AB minus BC. Okay, now let us come. So 1 0 0, A, B minus A, C minus A, BC, CA minus BC, and AB minus BC. Now you just keep this as it is, 1 0 0. Here this is A, this is B minus A, C minus A, BC. You can remove the common factor. C is the common factor, what you will get? A minus B. Here B is the common factor, you will get A minus C. Now this is equal to 1 0 0, or I will write 1 A B C. So here you can remove B minus A or A minus B as common factor, anything, it depends upon the problem. So here you can remove. So what you are going to take? Let me take A minus B common factor. So 1 0 0, A, B minus A, C minus A, B, C. C is the common factor, A minus B, B is the common factor, A minus C. So in the second row, you can remove A minus B as common factor. So A minus B out. So here you can remove C minus A as the common factor. So here 1 A, B, C as it is. I am removing A minus B means B minus A. B minus A can also be written as minus of A plus B. If you remove minus, you will get minus. So B minus A is also minus of A minus B. Therefore, what is left over is minus 1. Here it is C. So you are removing C minus A common factor 1. So A minus C can also be written as minus of C plus A, minus out. This is C minus A. So this is minus B. Right. Observe. So 1 0 0, here 1 A B C as it is. Here we are removing A minus B means B minus A is also equal to minus of A minus B, minus 1 and plus C. You are removing, what is the common factor? C minus A. A minus C can also be written as minus of C minus A. So for C minus A it is 1 and minus 1 into B is minus B. Now convert this element as 0. So how to convert this element as 0? Just add. If you add 1 minus 1, what happens? 0. Then this will reduce us to 0. So how to add? What is the property? R3 dash is equal to R3 plus R2. R3 dash is equal to, taking R3 dash is equal to R3 plus R2. This is A minus B into C minus A. So 1 A B C as it is, 0 minus 1 C as it is. Add these two. If you add 0 plus 0, it is 0. 1 plus of minus 1, 1 minus 1 is equal to 0. Minus B plus C is, this is C minus B. Now, so this is equal to A minus B into C minus A. See here all the elements below the principal diagonal are zeros. Therefore, this is equal to product of principal diagonal elements 1 into minus 1 into C minus B. So this is A minus B, and this can be written as minus of minus of 1 into C minus B can also be written as minus of B minus C into C minus A. So this is A minus B, minus into minus plus B minus C into C minus A. That is the required RHS. That's all. That is regarding the answer. RHS is concerned. Listen, let me explain once again. From the previous part, we are getting 1 0 0 A B minus A C minus A B C into, here you are going to remove C common factor, C into A minus B, A is a common factor, A into B minus C. So first row is same, 1 A B C same. Here you can remove A minus B common factor, A minus B common factor 0, B minus A is also equal to minus of A minus B, therefore you will get minus 1, A minus B is gone C. Here C minus A common factor, A minus C can also be written as minus of C minus A. So A minus B, C minus A common factor, you will get 1 A B C, 0 minus 1 C, 0 1 and minus B. So convert this element as 0. For this just add R2 plus R3. If you add R2 plus R3, plus 1 minus 1 gets cancelled 0. Taking R3 dash is equal to R2 plus R3. This is same, A minus B, C minus A, 1 A B C, this is same, 0 plus 0 0, 1 minus 1 is 0 and C minus B, B minus B plus R, B plus C or C minus B. So since all the elements below the principal diagonal are 0, so therefore this is equal to 1 into minus 1 into CB, minus of CB can also be written as plus B minus C, C minus B minus C, minus of C minus B can also be written as minus into minus plus and this is minus C minus into minus plus, or this is nothing but B minus C. So A minus B, B minus C and C minus A is the required answer. So that is the answer what you want to show, that is to be proved. Okay, so just practice, you will get an idea. Now let us take one more problem. So that is, what is the problem given? B plus C, A, B, C plus A, B, C, C and A plus B. Now, so this is equal to, what is this equal to? The answer is 4 times A, B, C. Now let us take LHS. What is LHS here? LHS, B plus C, B, C, again A, C plus A, C and A, B and A plus B. Now try to simplify as much as possible. So at a stage, if it is not possible to simplify, just expand with respect to first row, that's all. Now let us take the LHS. What is LHS? B plus C, B, C, A, C plus A, C, A, B and A plus B. Now let us taking R1 dash. R1 dash is equal to R1 minus R2 minus R3. Let us subtract this. So first, second row and third row are same. B, C plus A, B, second row. Third row, C, C, A plus B is same. Now, so we are subtracting R1 minus R2 minus R3. First element, this is R1, R2 and R3. First element of R1 is B plus C minus first element of row is minus B minus C. So what you will get? Minus B plus B gets cancelled. Minus B plus B gets cancelled. Plus C minus C gets cancelled. This reduces to 0. Now let us come to the second element. A minus of C minus A minus C. So observe carefully. What happens? Which elements gets cancelled? So here minus A plus A gets cancelled. Minus C is minus 2C. Similarly, come to this A minus B minus A minus B. Observe carefully, what are the elements going to get cancelled? So here plus A minus A gets cancelled. Minus B is minus 2B. Only first element becomes 0. Remaining second element is minus 2C and minus 2B. Okay. So here R1 dash is equal to R1 minus R2 minus R3. R2 is same, B, C plus A. R3 is also same, C, C, A plus B. Subtract this, B plus C minus B minus C is 0. A minus C minus A minus C. A minus C, A plus A minus C minus A minus C multiply by negative sign, minus A plus A gets cancelled, minus 2C. Again a minus b, minus of a minus b is minus a minus b, minus a plus a gets cancelled, minus 2b. Now, so what you are going to do this? So here you cannot further simplify, just expand this, that's all. Expand with respect to first row. So how here 0 into this is gone, 0 into number you will get 0, 0 into this is 0. Let us come to this. I will take this to the next page. Let me take, that is 0 b and c, 0 b c, minus 2c c plus a c, minus 2c c plus a and c, again minus 2b b a plus b, minus 2b b and a plus b. Now, so maximum what you can do, so you can subtract. If you subtract minus 2c, it becomes minus 3c, and a plus b minus, it becomes plus 3b. If you subtract like this, this becomes b minus c, so 1 c plus a minus, it becomes 2c, again it becomes 3b. So it won't reduce us to any property. So now here you just expand this, that's all. Plus, minus and plus. So 0 into number is 0, minus into minus plus 2c into, this is b into a plus b, minus c into b cb. Again plus into minus, minus 2b into, remove this column and row, b into c is bc, minus c into c plus b. Okay, expand, that's all. 0 into any number is 0, minus into minus plus 2c, delete the row and column containing this, b into a plus b minus c into b, minus into plus, it is plus into minus, minus 2b, delete the row and column containing this, what is left over is b into c is bc minus c into c plus a. So just you keep this c, 2c as it is, multiply this, b into a is ab, plus b into b is b square, minus c into b is cb, minus, just keep 2b as it is, multiply it, b into c is bc, minus c into c is c square, minus c into a is ac. Now multiply with 2c, 2 into c into ab is 2abc, plus 2 into b square into c, b square into c, minus 2 into b as it is, c into c is c square. See here, 2c into abc is 2 times abc, 2 times abc, 2c into abc is 2 times abc, 2c into bc is 2bc square, minus into plus minus 2 into c square is 2bc square, minus same type 2 times b into b is b square c, minus into minus, plus 2 into b into c square, minus into minus, plus 2 into b into a into c is a b c. Cancel the terms which gets cancelled, c, plus 2bc square minus 2b square c, plus 2b square minus 2b square c gets cancelled, minus 2bc square plus 2bc square gets cancelled. What is remaining? 2abc plus 2abc. This is equal to 4 times abc, your RHS. This is the required answer. Okay, let us explain once again. Come back. I will explain once again. Come back. So take LHS b plus c a, b c plus a b, c a plus b. This is the LHS. R1, just R2 and R3 are same. We are interchanging. R1 is equal to, subtract R1 minus R2 minus R3. So subtract this. B plus c minus b minus c is 0. A plus c minus a minus c is equal to minus 2c. A plus b minus a minus b is minus 2b. So I will take this to the here, next page. 0 bc minus 2c c plus a minus 2b b. So you can't simplify further. Expand it very easily. You will get the answer. So this is 0 into number is 0, minus into minus plus 2c. This is delete the row and column containing this, b into a plus b minus c into b, plus into minus minus 2b. This is gone. B into c is bc minus c into c plus a. So multiply first these two. B into a is ab plus b square minus cb. Multiply this bc, c square minus ac. Now multiply by 2. So this is 2c. 2c into abc is 2abc plus 2b square c minus 2c square b. Here also minus 2b square c, minus into minus plus 2bc square, minus into minus plus 2abc. Cancel the terms which gets cancelled, plus 2b square minus 2b square c gets cancelled. Again 2bc square minus 2bc square plus gets cancelled. What is remaining? 2abc plus 2abc, that's equal to 2abc plus 2abc is equal to 4 times abc. That is the required answer. 2abc plus 2ab is equal to 4 times abc. That is the required RHS. Okay. That is regarding how we are going to evaluate the problems based on the properties. Okay. Now let us come to the last problem. Next problem, prove that x, y, z, a, b, c, x plus a, y plus b, z plus c. Very simple. Observe carefully. Let us take LHS. This is very simple problem. What is LHS? X, y, z, a, b, c, x plus a, y plus b, z plus c. This is to be equal to 0. What is to be proved? This is equal to 0. Observe carefully. Since this contains x plus a, y plus b, z plus c. If you add these two, what is going to happen? X plus a, x plus b, z plus c. Two columns are same. You will get the answer. So, therefore, taking C1 dash is equal to C1 plus C2. So, that is, you just keep this as it is. A, B, C, x plus a, y plus b, z plus c. Now add this first element of column number 1 and column number 2, x plus a. Again, second element, y plus b. Third element, z plus c. So x plus a, y plus b, z plus c. So you can remove the common factor, or straight away you can say, since two columns are same, first column and second column are same, therefore the value of determinant is equal to 0 because two columns are same. First column and second column are same, x plus a, y plus b, z plus c, x plus a, y plus b, z plus b. Therefore, this is equal to 0. The simple way, that's all. See here, taking LHS, x, y, z, a, b, c, x plus a, y plus b, z plus c. So, taking C1 dash is equal to C1 plus C2. Add this, x plus a, y plus b, z plus c, a, b, c as it is, x plus a, y plus b, z plus c as it is. Observe carefully. First column, x plus a, y plus b, z plus c. Third column, x plus a, y plus b, z plus c. First and third column are same. If two rows, two columns are same, according to the property, the value of a determinant is equal to 0. So, therefore, this is equal to 0 because two columns, that is first and third column are same. That's all. Very simple. Within 2 steps, you will get the answer. You will get 3 marks very easily. Okay. Usually, you will expect this type of questions for the examination. So, that's regarding for the day. So, in the next class, I will take a few more problems. Don't miss, attend the class. So, I will take few more problems based on these properties. Don't miss the class. Thank you very much. Thank you.